Yes, dear students, here a question. The distance between Sun and Earth is 2.5 into 10 to the power 4 times the radius of Earth. Mass of Sun is 3 into 10 to the power 5 times the mass of Earth. A rocket is to be launched of mass m. Now, so that it goes beyond the pull of Earth and Sun both. We have to throw any particle or any rocket just to go beyond the pull of Sun and Earth. So what should be the minimum approach to speed? Vs. If Vs is the speed of the rocket, so that it goes beyond the pull of Earth and Sun system, then Vs is equal to the other option Vs close to 62 km per second or 22 km per second or 72 km per second or 42 km per second. This rocket has to leave the in one sense solar system, neglect other effects. Actually, when it will go beyond the pull of Sun and Earth, then total energy will be zero. Total energy becomes gravitational energy and kinetic energy. So if Vs be the speed, then total energy will be half mvs square minus gmem upon re. Potential energy on our surface, and potential due to attraction of sun will be g into उसका मास है 3.5 into 10 to the power 3 into 10 to the power 5 me into m upon distance है 2.5 10 to the power 4 re, and when it goes beyond the pull it should be zero. Simple fact is this. From this we have to find out Vs. So half mvs square is equal to, this will all become positive, and gmem upon re common. So 1 plus 3, this will be actually decimal here, 10 to the power 1, 300, it will be 12. This solution, this will come out 12. How? By it is 3 into 10 to the power 5 gms upon 2.5 10 to the power 4. तो 10 ही बचेगा, एक हिस्सा गया 300 upon 25 12. So it will be 13 gmem upon re. And we are given here that V escape from Earth is 11.2 km per second. Escape velocity of any object from Earth's surface is this. This m cancel. So Vs square 13 into 2 gme upon re, and this is escape speed. This is escape speed, that is this kilometer per second. Square of that. So V equal to under root 13 under root 2 gme upon re. But from our surface, Vs is the same. V escape under root 2 gme upon r, which is given 11.2. So here I can put root 13 into 11.2 kilometer per second. Root 13 is 3.6. If we find under root 13, 3 3 9 4.00 and 6 6 36. So this V come out 3.6 into 11.2 kilometer per second, and it comes 40.2 kilometer per second, which is nearly 42 kilometer per second, closest. This is the answer here. So such questions are required to do by you, dear student, in competitive exam. Questions asked are based on fundamental facts. They don't require a long calculation. There are some books and question banks which keeps you busy in solving the calculation. But in competitive exam, the question is said that you need not to do so many calculations. Now I come to next question here. The mean radius of Earth is RE, its angular speed omega. Earth जो है, Earth rotate around itself with speed omega. It radius RE, and G is the extent to gravity. G is the extent to gravity. The cube of the radius of geostationary satellite. The cube of the, यहाँ भी क्या पूछा आपसे? Geostationary satellite. Somewhere उसका जो रेडियस होगा ऑर्बिट का, that r, cube of that equal to, there are options given here. A option is there. Let me write here. A option is RE square G upon omega. B, RE square omega upon G. और C है REG upon omega square, and D is RE square G upon omega square. I think you have got question. Earth rotates about its axis with angular speed omega. Every radius of Earth is RE. Accelerative gravity on the surface is G. So cube of the orbit, radius of the orbit, is related from any of these four options. Which one is that? So which satellite is called geostationary satellite? A satellite whose time period is equal to time period of Earth. Time period of Earth. If omega is the angular speed of the Earth, then time period of T बराबर 2 pi upon omega. If omega is the angular speed of rotation of Earth, then T is this, and time period of satellite is 2 pi under root R cube upon GME होता है. Is that clear? Remember this formula, time period of satellite, and this time period of satellite is equal to time period of Earth. So therefore I can write 2 pi upon omega, 2 pi under root R cube. GME actually small g equal to GME upon R square होता है. Is that clear to you? So in place of GME I can write here GRE square. 2 pi cancel. So root का जाता है 1 upon omega square is equal to R cube upon GRE square. So R cube is equal to GRE square upon omega square. GRE square upon omega square. Fourth option is correct. by here r e square g upon omega है. So sometimes you will get some simple questions, but you need concept, and concepts are learned by practice, nothing else. Do as much question as you can do, and try all questions at one time. When you sit studying question, at least you should try at least 20 or 25 questions in 1 hour. Then only you will can increase your speed. Now there is one more good question here. The ratio of escape velocity at Earth VE to the escape velocity of at planet VP, whose radius and mean density are twice that of Earth. If VE is the escape velocity from Earth, and VP be the from planet. Planet has, if its density rho and radius r, its density 2 rho and 2 r the radius. So what is the ratio of VE upon VP? What is VE? Escape velocity from our surface. VP escape velocity from planet, whose mean density twice that of Earth, mean radius twice that of Earth. Is that clear? थोड़ा यहाँ reflection है. What I am telling, V is the escape velocity from Earth, whose density rho radius r. VP is the escape velocity from planet, whose density twice that of Earth, radius twice that of Earth. Now, how to solve this? You know escape velocity VE under root 2 GME upon RE. Now you need mass into density. Mass of Earth होगा mass ME 4 by 3 pi RE cube into rho. So if I put it here, then VE will come out to be 2G into 4 upon 3 pi RE cube rho upon RE, which is equal to यहाँ लिखते हैं 4 2 जा 8 by 3 pi G RE square rho. This is the expression for escape velocity in terms of gravitation constant, radius of Earth and density of Earth. Now VP velocity the same way, under root 3 by 8 pi G RE twice RE. So 2RE whole square means 4RE square into rho, उसकी होगी 2 rho. तो इट सिंपली VP जो है इक्वल टू 8 into 3 upon 8 pi G R square rho. This is VE, this is VP. So VE upon VP. VE upon VP under root 8 by 3 pi G R square rho upon this is under root 8 into 8 by 3 pi G R E cube rho. So what you will get here? You will get VE upon VP equal to 1 by root 8 If you cancel, it is 1 by 2 root 2. So here PE upon VP come out to be 2 root 2. This is again a simple question here. I hope you will be understanding my solutions easily. But dear student, we have to do a lot of work. There is one question which confuses the student. I told you, and that video has been viewed by many people and liked by many people. Gravitational field intensity, general formula of gravitational field intensity of Earth. क्या बताया था हमने? मैं फिर बताऊंगा बात तो ये कह रहा डिपेंडेंस ऑफ इंटेंसिटी ऑफ ग्रेविटेशनल इंटेंसिटी ऑफ अर्थ विद डिस्टेंस आर फ्रॉम सेंटर ऑफ अर्थ इज करेक्टली रिप्रेजेंटेड बाय intensity of gravitational field intensity. हाँ भाई, here you can write I or this side R. So graphs are like this. One graph is this way. This is R, and here R equal to ये R है. Option A. What is option B? Option B like this, R and I, like this. Again R equal to RE, radius of Earth. और कोई बॉडी हो, dependence of intensity of gravitational field of the Earth and the distance Earth का जाएगा. And the C option is there. Like this. And last option I and R. तो ग्रेविटेशन पोटेंशियल एनर्जी is the force of attraction per unit mass. और attraction force किधर रहेगा? Listen me very carefully. If mass m is here, force is this, and r vector direction this. So therefore, intensity of gravitational field from Earth's surface inside that G m e r upon r e cube होगा. Where r is the distance from center of Earth. If r less than re, this thing constant. Yes, dear friend, here potential energy. I told you, I'm telling that it is I minus J upon re inside Earth. If r is less than re, then it is this. So inside this constant. And therefore I put minus r at Earth surface minus this. So correct option is हमारा A. Because linear is proportional. This is wrong. Because positive, this is positive. This is curve. That's why it is wrong. So correctly the intensity is represented by this graph. So I have done some question for you of gravitation. There is no end actually to the problems. You keep on doing yourself. Thank you.